All right, so the title of today's talk is TypeScript. You'll like it. You can't see my slides, right?
Yes, you're fine. Thank you.
Great. So hey, everyone. It's great to be here at Scale by the Bay. Well, not really here, but here online anyways. I know we're all figuratively in Oakland, California right now by Lake Merritt. We're actually all online working from our own homes, but it's nice to think that sometime in the future we'll all be back together, but I'm glad we could all meet together here today. I'd like to go ahead and introduce myself. My name is Jason Swartz, and I'm a big fan of Scale by the Bay. I used to help out when it was Scala by the Bay, and I know we're all multi-language and multi-methodology here. I wrote Learning Scala from O'Reilly, so I'm a big Scala fan, but I like other languages too. And during my time at different companies, I've enjoyed doing Java and Python and JavaScript and Go and TypeScript. So I want to talk about TypeScript today. So here's the agenda for today's talk. I'd like to talk about what it is. I'd like to talk how you should probably use it. And 3, why should you use it? Let's jump into the first topic. What is this TypeScript I'm talking about? Basically, you've heard of JavaScript. It runs in the browser. It runs on the command line. It powers services. It's a very popular language. TypeScript is essentially JavaScript plus types. Thus the name, TypeScript. And that's the whole talk. That covers everything. No, there's a little more to cover than that. I'm just kidding. But yeah, TypeScript is essentially JavaScript with types. So this is a language that goes back to 2012. Microsoft created it and they've been supporting it. It's a very well supported language. They're great documentation site. And it really does do, it's really nice to have a strong supported language. It essentially supports everything that's in JavaScript ES6. This was the second big version of JavaScript, really overdue. Adds a lot of niceties, has a pretty good collection library. TypeScript is basically on top of ES6. So if you're familiar with ES6 and having classes and organizing your code into modules and using lambdas, it's very similar to that. It is a compiled language. There's a compiler called TSC that you'll run to compile your TypeScript into super optimized and minimized JavaScript before you then deploy it, say for a server in Node.js or to the browser. So there is an extra step that you'll want to do when you want to run your TypeScript, somewhere. Some of the features, I'd like to go into them. The what of TypeScript? Well, nice thing is you do have types. You specify them actually kind of similar to Scala style after the name of your variable or constant. Another nice thing is you actually don't have to specify the type. The types are optional. TypeScript compiler does use type inference. So in this first example, const is flag. Well, if you're setting it to true, the compiler will figure out that this is a Boolean. Another nice thing is you have support for generics, as you have in Java and Scala and some other languages. Here's an example of creating a users array where I'm saying I want to create a regular array similar to JavaScript, but with the type user with the starting capacity. Now, if you try to add this is a mutable array, but if you try to add something that's not a user, you'll get a compilation error. So it's nice to have, if you're familiar with generics, it's really nice to be able to have them in other languages to make sure that you can really express what the type of your data collections are. Last thing is you do have type aliases. So for example, here's a container T is something which is a object or object literal in TypeScript with a value T. T here is simply the generic type parameter that's being passed in. So I can then reuse this in my constants and variables and have them as type container T. For example, maybe value is a string or an integer or an instance of a class. Next set of features in TypeScript, null checks, which is really nice. One of the options you have for TypeScript, the TypeScript compiler, is it can go through and figure out, well, do you have possibly null situation here? So here's an example where I have a name variable and I'd like to assign this to another variable called user. The TypeScript compiler would then flag this if you have strict or strict null checks set and say, well, this looks like a null condition, you should probably check here. Another nice thing is chaining. You have the question dot operator to say, well, go ahead and call the bar method and get the bar field and then call the baz method if foo is non-nullable. If it is null, do nothing. So in this case, X would be null if foo is null. Otherwise, it'll get the bar field and call the baz method. Another nice thing is coalescing. And these are really nice checks to have because you don't want to have null exceptions happen in your web application in production. So coalescing, here's an example. If foo is null, it'll do nothing. If foo is not null, it'll go ahead and call the bar method. Anyways, really nice that TypeScript has some easy ways to prevent null errors from happening in production. Next feature I'd like to go over is, well, more types. If you're familiar with ES6, you're familiar with function literals. Here's an example of a, let's see. Here's an example of a function literal called dub, takes a number, and number being the base type for numerics in TypeScript, takes a number and doubles it. This lambda notation is really from ES6, so it's really a JavaScript holdover, but since all of ES6 is supported syntax in TypeScript, this works out. The nice thing is with TypeScript, you can say, okay, this definitely takes a number. One thing I could add to this too is to say, not only does this take a number, but this, well, sorry, I have that here. This takes a number, it has an arrow and says it returns a number, and I'm assigning it to a lambda which multiplies by 2. Object literals, something you have in a JavaScript. This is behind the whole idea of JSON, really, of saying, hey, let's just use braces and define some type of immediate object, or similar to a dictionary in Python, for example. Well, the nice thing is it's not really a dictionary. Here I'm just specifying an object with types. So I'm saying, look, this is an object, but with I'm specifying an object here, literally, which is really nice. TypeScript, like JavaScript, isn't super concerned about defining your classes first. Another nice thing, especially for fans of Scala, is you do have tuples of various sizes. In this case, here's address. This is a tuple of 2 fields, heterogeneous types. Here a string and a number, and we're assigning it to a literal value. Something that's really nice to be able to work with. And of course, you get all the favorites that are defined in JavaScript's ES6. You have classes, you have inheritance and basic polymorphism, which is nice. You do have all the collections like map and set and array and all the others that are defined for JavaScript. In this case, we're really putting generics to good use here. Here's a map from a string to a number, and here's an empty set of just strings. And since this is ES6, you do have a lot of really useful data collection methods. Here's an example of creating an array of items and then mapping them to double their value. And this is standard TypeScript. It is respecting the types here. If I gave it a lambda, for example, that added it to a string, for example, it would definitely, I'd definitely be getting a different type back. Let's see, I'm not sure if we're taking questions here or afterwards, but I'm happy to be interrupted anytime with questions. Like How do you pick your fonts? And other good TypeScript questions.
Thank you.
All right, you're probably thinking, okay, this is just language things. Where's all the other functionality I want to add? Well, that's cool. You can go ahead and choose all kinds of wonderful add-ons for your TypeScript project. In this case, here's a demo of using Yarn, which is similar to NPM. This is the package manager for TypeScript and JavaScript. In this case, I'd like to say, ooh, I'd like to get React, but not just React. I want the types and the whole document object model as well for this. Yarn will go ahead and get the TypeScript data that I need, so I can create a nice simple React page. Here's an example of where I'm using what's called TSX, which is like JSX. I'm using inline HTML, and I'm defining a React app here. This return, I'm adding on the return type from this function and saying, okay, here's a basic element in JSX, but using TSX with very safe types. Let's say I want to get a little 3D. Okay, I can just simply say yarn add 3 and start using it from TypeScript. Here's an example of a basic view with 3JS. I have types for all of everything I need in 3JS. Setting up I have a constructor, which is a core part of any TypeScript class, and an update method. It's a little verbose, but that is 3JS. The nice thing is, for almost any top JavaScript project you're looking for, someone already has the types available for TypeScript. So you can usually depend on the types that you need being available. Okay, last add-on, because you're probably wondering, and this is Scale by the Bay. Yeah, there's a lot of functional libraries for TypeScript, which is really nice. FPTS is one of the most popular ones. And with that, you get a lot of Scala style add-ons such as option. Here's an example of a parse function. Well, I'm going to try to parse your string into a number. So in case you give me something that's not actually a number, I'll set the return type to an option containing a number and check, okay, is this not a number? Okay, is it actually divisible by 1? Okay, so if it's not divisible by 1, if it's not a number, I'll return num. Otherwise, I'll wrap this with sum. Really nice to have. I recommend this. I've enjoyed FPTS, but there's a lot of different TypeScript functional libraries to choose from. All right, well, that pretty much covers the what is TypeScript. Next thing you're probably wondering is, okay, how do I get started using TypeScript? Well, it's pretty easy. I'm going to walk you through setting up from the command line, assuming that you have Node.js installed and Yarn installed. Yarn used to be the best package manager. I think Node has caught up now. So whether you use Yarn or NPM, if you install them with Homebrew, you can get the rest of the way. In this example, I'm going to use Yarn. And I'm going to say, hey, I'd like to add a package, and I want it as a dev dependency because I want to be able to compile against it, not just a runtime dependency. Well, the first package I'm going to add is TypeScript. That's right. I want full TypeScript support plus TSC, the compiler, to be installed for this project. I'd like to get the core types that are available for Node. Node adds the map and set, pretty nice collection library. It adds HTTP client, it adds ways to call shell commands. So I really want to make sure I get all the types there. And I'd like to have a REPL because I don't really trust my TypeScript coding and I want to test things out in a REPL first. So TS Node's kind of fun. You can run this as a local REPL and test your TypeScript code out. Next thing, so when you run Yarn the first time in an empty directory, it'll set up package.json. This is what manages your dependencies, has your configurations for your project, also has a number of, you can add scripts in here and shortcuts so you can more easily execute your project. In this case, I'm just adding types, TS Node, and TypeScript, all the latest version as dev dependencies, so they're available at compilation time. Next thing I'm going to run is TSC itself. In this case, so TSC is the TypeScript compiler. I'm going to say init, which says, please set up a standard project. And a TypeScript project is a single file called tsconfig. So when I run TSC and I say, I want, please initialize the project, it'll set up a standard tsconfig.json with the compiler options. The target is, what JavaScript code style are you emitting? What modules do you need access to? How exactly are you going to be able to call JavaScript code? And my favorite in the middle is strict, which says, look, do you want strict null checks? Do you want strict type checks? Do you want me to do extra compiler work to make sure that your code is going to run successfully? Once you have tsconfig.json in there, you have package.json, which is necessary for Yarn, which adds the dependencies like TypeScript. We have tsconfig.json, so now we have the configuration for our TypeScript. We can now run the REPL. We're all set. Here's an example of using the REPL. Let's see, I'm going to add an import. So TypeScript uses modules. It uses the ES6 ID of modules. So I'm going to go ahead and import exec from child process, which is included with node. Well, we added the node type, so we have access to all of the calls. I'm going to set up a string and execute an ls in this directory, which just has our node modules package and package.json. I'm going to get the standard error, standard out. I'm sorry, an error message, standard error, standard out, and standard error. Take that and just grab whatever is printed out by standard out. And then I'm going to go through all of the items in here and print them out. Let's see what I have. Oh, I have node modules package.json. Okay, minor error on my part. I did skip a line where I then split what's in string into an array called files. Sorry that that's left out. But the last thing here is you call split, similar to what you do in Scala or tokenize in Java, and convert this into a simple array. Another quick demo. Let's say that you have, let's say I take that standard out, and I want to serve my directory list as an HTTP server. Well, there is an HTTP server that's available in Node, so now it's available in TypeScript. I can create the server and say, look, when I get the request, go ahead and call response.end and give it this content and send it back, and let's listen on port 80. And as a result, I now have a nice fast server up and running, serving the directory contents. I can change this, of course, to simply serve the file contents or serve this as an index.html. This is just a super simple way to be able to code things up in the TypeScript REPL. All right, with 10 minutes left, we covered what is TypeScript, and we covered how do you use it. The question that I probably should have led with is, well, I already know other languages. Why should I use TypeScript? Well, one of the most popular ways to use TypeScript is to build websites. For example, Vue.js is really popular. It uses classes. It's really clean. There's a lot of great templates out there for using it. There's actually a really popular one on the Armor site, which has a Vue.js admin, everything you need in TypeScript. Since it's all type safe, you can make changes and verify and run it in dev mode. The Vue.js is super popular. Of course, the elephant in the room is React from Facebook. Really, really popular way to build sites. That's what we're using to build Twitch, for example. Twitch is built in React. We're using TypeScript so that we can catch everything on our CI instead of in production. Angular, finally, is the other really popular one, predates React. Still a really popular way to build websites. And the core thing is, whether it's you building it, or let's say you have a small project and you want to hire someone to build this, if it's TypeScript, you'll have your compilation checks done. You can catch errors before they go into production. And if you're familiar with the code, you have more people who can read the front end code. So that's websites. But maybe you're more a business in front, party in the back developer, and you're not really into the front end so much. That's okay. Maybe you'll use TypeScript to build apps. For example, Express.js is one of the most popular way to build a Node.js server, and Node.js's servers in Express are powering tons of some of the most popular sites around. You may say, well, I don't really want to build an app. I want to build iOS, or I want to build an Android app. Great, React Native. Very similar. You have all the typings available in TypeScript. You can use this to build both iOS and Android. Really useful. You may want to set up infrastructure, for example, with Pulumi or AWS Cloud Development Kit, they support TypeScript. You can define all of your infrastructure, for example, with AWS CDK in TypeScript. The types compile when it runs, it'll check with you, generate the CloudFormation, and ask if you want to go ahead and set up your infrastructure. Really nice, compact, and type-safe way to build out your infrastructure. If you're building a CLI in Node.js, which I like building out CLIs, there's a Twilio page that has an overview of the top CLI picks. Really, there's a lot of great options. A lot of these are JavaScript, but they do have TypeScript types, and they make it really easy to build everything you need to have a really rock solid CLI. Last thing in there I threw in there is package. Package will build your Node.js as a native executable for your platform, so that if you want to distribute it to others, for example, as a Mac binary or a Linux binary or Windows binary, makes it really simple to set that up. I'll pause here. I know this is kind of an information-rich slide. Well, you could also use it just to build JavaScript libraries. For example, Nest.js, very popular framework for backend. This is built with TypeScript. Jest is crazy popular. It's a testing library. You probably figured that JavaScript plus test equals Jest. Actually built with TypeScript, used by JavaScript libraries and TypeScript projects all around, but it's actually built with TypeScript. And lastly, Angular. Angular is actually built with TypeScript. Even though this is a super popular JS project, they figured, well, we should probably compile everything before we actually build this into JavaScript to catch any errors. So not only can you build apps, websites and apps and CLIs, but you can build reusable JavaScript libraries with TypeScript. All right, last part is you might say, do I really need to have a TypeScript though? Well, you don't really have to. If you want to build something in a language that compiles to JavaScript, for example, to build a great website, you can go with Reason. Reason is super popular. It's very functional, based on the OCaml syntax. It's a really nice language. Elm, really popular for websites. It's also functional, has a lot of great tooling on top of it. And you can also go with Scala.js, very well supported. If you like the Scala syntax, you get to keep it. A lot of great library supports. I think there's Cats and Zio now for Scala.js. So you have a lot of options. You don't really have to do TypeScript. If you are going to build a website, I recommend building something which does have great types though. So TypeScript, Reason, Elm, Scala.js, these are all great options for building out your own apps. TypeScript though, last part, it is the more popular choice. So you could go with JavaScript, but since TypeScript's compiled, it's very well typed, you're going to catch bugs earlier. You have great editor support, so you can click through straight into types. You can navigate much better. You clearly build better tools if the tools understand the types. And it's very loved. So if you're going to start a project and you want to bring on other engineers and find engineers with similar skill sets, TypeScript is a great choice. It's very well understood, and a lot of folks use it. A good reason to go with TypeScript. And maybe I've had fun using it too. All right, that is the why. That concludes my talk. Thanks for listening. Thanks for watching, everyone. It was really fun to talk about TypeScript today.